Hi, welcome to Resolve Chemistry. Let us continue our discussion on this ionic equilibrium. In the previous video, we have discussed various concepts of acids and bases, where we have seen Arrhenius concept, Bronsted and Lowry concept, and Lewis concepts of acids and bases. Okay, in the present video, we will discuss a very interesting topic, that is ionization of acids and bases and the relative strengths of acids and bases, and how the strengths of acids and bases are going to vary based on the type of solvent we are taking these acids. Okay, so let us continue our discussion. So first one is ionization of acids and bases. Well, according to Arrhenius theory, we said that any compound which upon dissolution in water, if it furnishes H plus ions, we called as acid, and any compound which upon dissolution in water, if it gives OH minus, we called as what? Base. Alright. So now the thing is, if you dissolve in water, okay, so to what extent it is giving H plus ions, okay, based on that we call them. If any compound which upon dissolution in water, okay, in water, if it undergoes, almost it will dissociate to give, okay, maximum to H plus ions and A minus ion. So then if it furnishes more and more H plus, more and more when it is possible, when it undergoes maximum dissociation. So any compound which upon the dissolution in water undergoes dissociation or ionization to almost complete extent, then that acid we called it as what? Strong acid. Any compound which upon dissolution in water undergoes complete ionization, almost complete we can say, to furnish H plus ions or to give more number of H plus ions is said to be strong acid. Similarly, if that undergoes partial dissociation, means to only small extent if it dissociate and gives only few number of H plus ions, then it is called as weak acid. Okay. Similarly, when you take a base, okay, BOH, which upon dissolution in water, if it undergoes complete dissociation to give more number of OH minus ions, okay, then it is called as strong base, okay, according to Arrhenius concept, okay. Then second one is, if it undergoes partial dissociation or ionization to give only few number of hydroxyl ions, then it is called weak base. So according to this Arrhenius concept, so like your H2SO4, HCl, HBr, HClO4, all these will undergo almost complete ionization to give H plus ions, hence are called strong acids. Okay, and similarly CS3COOH, okay, HCOOH, etc., which undergo partial ionization, okay, hence give a few H plus ions, hence are called weak acids. Okay. Now we will move on to next is according to Bronsted and Lowry theory. Similarly, how we will explain this ionization of these acids and bases. Okay. According to Bronsted and Lowry theory, acids are what? Proton donors. Proton donors are called acids, and proton acceptor proton acceptors are called bases. Okay, so we will see that one. Okay, we will take one simple example. Now suppose you take HCl. Okay, when you dissolve in water, here what happens? So water will accept the proton and form hydronium ion and Cl minus aqueous. Okay, means here HCl is giving the proton and water is accepting the proton and converting into hydronium ion and Cl minus ion. Okay, so now it is completely dissociating and giving H plus ion to water molecule. Now we should say that our base, that is water, is also having greater tendency to accept the proton. We can say that one. When it has a greater tendency, then only it will take back. Okay. So now the strength of this HCl not only depends upon HCl, it also depends upon the strength of a water molecule to accept the proton, first thing. And second thing is the what we call the conjugate base, what is being formed. Okay, how much strong it is or weak it is, that also decides the strength of an acid, that we will see. See here, it is an acid as it is donating the proton, and water is base. Okay, it is accepting the proton, and your hydronium ion, as it has got with an additional H plus, so therefore it can donate, so therefore it can act as what? Conjugate acid. Okay, and your Cl minus will act as what? Conjugate base. Okay, so now leave apart your HCl. Let us look into Cl minus. If the Cl minus is what? If it has greater tendency to, or it is highly unstable, if we say. Okay, so if it is highly unstable, then what happens? Immediately it will take up the proton from hydronium ion, and once again it converts back to HCl. Okay, so as it has lowest tendency to accept the proton back from hydronium ion, so therefore it is a weak conjugate base or weak base we call. Our Cl minus is weak base, whereas this water is a strong base, so therefore it will accept the proton and form the conjugate acid, and this conjugate acid is more stable. Okay, and we can say that it is a what we call, it's a weak base. So but here it is what? Strong is also, or we call it as weak acid. Okay, hydronium ion is acting as weak acid, and here chloride ion is acting as weak base. As these two are acting as weak acid and base, so therefore your HCl will be strong acid or greater proton donor, we can say, to water molecule. It will be strong base. Meaning is what? So when you take the conjugate pair, okay, if conjugate acid base pair, if a conjugate base is weak, then the said acid will be what? Strong. If acid is weak, then it means that your conjugate base of that acid will be stronger. Okay, we will take another example, then you will be very clear with this one. Now we will take acetic acid. Okay, now suppose if you take acetic acid and if you dissolve in water, okay, this is acid, of course, right? Then what happens? It will form acetate ion, aqueous plus H3O minus plus aqueous. Okay. Now when you look into this, so it undergoes only partial ionization. What is the reason for this? So this is your conjugate base, we call conjugate base, and this is conjugate acid. Okay. So now this acid is weak because it donates only few protons, means it dissociates to very small extent. Okay. Is there anything wrong with the water? Because here also we have taken water, here also same water. Only thing is that the acetate ion which is being formed after donation of the proton, after dissociation or ionization, that acetate ion is what? A strong base. Okay, it is acting as what? Strong base. So therefore it makes this H3O plus to give back the H plus ion, and it will recombine to give acetic acid. So if the conjugate base is strong enough to accept the proton back, then your acid will be said to be weak. If the conjugate base is weak, it has no tendency to take back the proton and form the acid. So therefore your acid will be said to be strong. Okay. So this is how we are going to explain based on the capacity of the acid to donate the proton and base to accept the proton. Okay. So after donating the proton, whatever the conjugate base is formed, if that base is a strong base, then what happens? Your acid is said to be weak. If it is weak base, then your acid is said to be strong acid. So therefore your HCl is what? Strong acid, whereas your acetic acid is weak acid. So this is how we are going to explain the ionization of acids and bases. Okay. Now let us see the relative strengths of these acids. Okay. So that we will see, and how those are going to vary with the solvent, that also we will see. Relative strengths of acids and even bases also we will see. Okay. So first we will consider acid. Now what we will do is, so we will take acid in different solvents, right? First we will take, say for example, strong acids like HCl. Okay, HClO4 we will take, then HBr we will take, then we will take H2SO4, HCl and HNO3. So we will take these 5 acids and we will try to compare their acid strengths. Okay, in different solvents. How the solvent plays very important role, we will see that one. So first we will take acetic acid first. Acetic acid, it is a weak acid. Always remember, the acid strengths and base strengths of any compound is a relative property. Okay, it is not a fixed property, we can say. Okay, so now your acetic acid is a weak acid, hence it can act as a base, weak base in presence of strong acids like HCl, H2SO4, okay, or perchloric acid. Okay, so now if I dissolve this HClO4, I will take one general example, Ha. When we will add to acetic acid, so then it will undergo partial ionization to give CH3. Here your acetic acid is accepting the proton, okay, and acting as a base, right? And acetic acid is acting as base, and here it is conjugate acid. So this is your base, this is your acid. Okay, so in acetic acid, when I dissolve all these acids, so they ionize to different extent. What is the meaning of that? So means perchloric acid is ionizing to the greatest extent, and we can give the strength, we can compare of these acids as perchloric acid is stronger acid than hydrobromic acid, which is stronger than H2SO4. H2SO4 is stronger than HCl. HCl is stronger than HNO3. Okay, means when I take such strong acids which we call as strong acids. We will come back in water, we will see that one, how they are said to be strong acids. When you dissolve in a weak acid, solvent what we are using, weak acid like acetic acid, all are going to ionize to different extent, and highest one will be perchloric acid, okay, and then hydrobromic acid is a weak acid, and hence it acts as a weak base. So therefore then it will differentiate all these acids, okay, the strength can be differentiated, okay. So therefore your perchloric acid is the highest acidic in acetic acid medium or solvent. Now let us compare in water, okay. So when same acids, when you take in water, water compared to acetic acid, water is a strong base, means strong proton acceptor. Then what happens, all these acids will ionize to the same extent, means HClO4 is equal to almost HBr, okay, ionization I am saying, equal to meaning is what, in terms of a extent of ionization, okay, H2SO4 which is equal to HCl which is equal to HNO3. The meaning is what, in compared to acetic acid, our water is a strong base, so therefore in strong basic medium it will accept the proton from all the acids to the same extent, okay. Still we can compare, like if you take acetic acid and all that, those are weaker acids in water also, okay, but all which we call it as stronger acids, all are ionizing to the same extent, and hence what we cannot differentiate their strengths, and this we call it as what, leveling effect. This is called as what, leveling effect, okay. Means in a given solvent, if all the acids are of equal strength, then that effect we call it as what, leveling effect. Further, if you see that weak acid like acetic acid, if you take, so in water again it ionizes to small extent only, and anyhow the weak acid like formic acid, acetic acid, we can differentiate from these strong acids, okay. But all these acids which are having different strengths in acetic acid, they have same strength they are showing in water, that you should remember, okay. Similarly, next what you do, you take all these acids including acetic acid in still more stronger basic compound, that is ammonia. If we take all these acids in liquid ammonia, okay, so then even acetic acid also, okay, even acetic acid also what, ionizes to what, in ammonia it will ionize completely, okay, and we cannot differentiate its strength with other acids. Meaning is what, even weaker acid like acetic acid is also behaving like a strong acid like HCl when it is taken in liquid ammonia, okay. What is the reason for that? Meaning is what, it is not the anything which is varied with acetic acid, it is variation in the solvent, okay. So here we have taken weak acid, base, strong base, still more stronger basic condition we are maintaining. Then what happens, even acetic acid also levels with your what, strong acids like HCl, HBr, HCl, perchloric acid and all that, okay. So that is how the solvent is going to influence on the strength or ionization of the acids, okay. You should remember that in liquid ammonia, acetic acid is behaving as good as your HCl as an acid, okay. Then let us look upon bases, how they are going to vary. See, when you have gone through all these acids like HClO4, HCl, HBr, okay, H2SO4, all these are what, covalent compounds, okay, and they ionize to greater different extent in different solvents we have seen. But if you consider bases like KOH, okay, lithium hydroxide, sodium hydroxide, okay, etc. So all these compounds are ionic, okay, in solid state itself. Okay, no need to ionize here because already they are in the ion forms in the solid state. Is it clear? So therefore, when such bases, okay, so always they will be having equal strength, right? But still what we see is when you dissolve these in water, okay, so in water when you dissolve, water is going to act as a good acid. So therefore here what we see is all are having equal strength, equal strength. Okay, similarly when they are added to acetic acid, okay, already it is a little bit higher or stronger acid than compared to your water. So therefore when you add all these acids along with the bases along with aniline, if you add, so aniline is also going to act as a good proton acceptor as good as your all these bases. Okay, so that we call it as what? Leveling effect in acetic acid. Means acetic acid, all the bases including weaker bases like aniline is also going to behave equally a proton acceptor. Okay, so this is all about the relative strengths of acids and bases in different solvent medium. Okay, I hope you have understood. Okay, so we will conclude. Okay, we will continue further aspect in upcoming videos. Thank you for watching and don't forget to subscribe our channel. Thank you.